Welcome back. Our videos in this mini-series have covered how we can assess the fit and validity of our model and how to use our model to produce counterfactual simulation. And these counterfactual simulations are the basis of our policy conclusions. And in this video, I'm going to discuss how we can bring in the uncertainty from our estimated parameter values, typically expressed as standard errors or confidence intervals, into our presentation of the counterfactuals or the policy effects of these as of yet unimplemented policies that we're experimenting with. This is a relatively new idea because counterfactuals are so demanding in most cases that it's difficult to have a requirement that all counterfactuals be attached with confidence intervals around them. But given computational advances and other technological improvements, it may be the case that this becomes more of a habit moving forward. So once we do our counterfactual simulations, we're going to get a new predicted distribution of y, for example. And then what some people might criticize is that we don't know what the confidence interval is around that new y. So if you say, well, wages go up by 15% on average if I introduce this job training program, that's great, but what's the confidence interval around that? That matters too for policy. And because the estimates that the counterfactual is based on have some uncertainty around them, we should be able to impose that uncertainty on the counterfactual predictions as well. And the way that we do this is through a type of bootstrapping that I'll introduce here momentarily. So basically what we're going to do is we're going to use bootstrap sampling not to sample from our data, but instead to sample parameter values that express the uncertainty of the estimates that we obtained from our estimation routine. And if you recall, if we're using a likelihood-based model, the negative of the inverse of the Hessian is the variance-covariance matrix around our estimates. And when I say Hessian, I mean the second derivative matrix of the likelihood with respect to the parameters. And then we're going to assume that our parameters are drawn from a multivariate normal that has a mean of the true value of these parameters, and the covariance matrix is the negative of the inverse of the Hessian. And then, just as a matter of practicality, we're minimizing the negative likelihood, and so in most cases we'll just use the inverse of the Hessian, not the negative of the inverse of the Hessian, because we've already taken the negative when doing the minimization of our likelihood. So what is the process that we follow? Well, we're going to sample capital B times from this multivariate normal distribution, and then we're going to recompute our counterfactuals for every sample that we take. And this will give us some measure of variation around our counterfactual conclusions. So to get the 95th or the 95% confidence interval, for example, we would just look at the 2.5th and the 97.5th percentiles of these whatever counterfactual statistics that we're interested in. And the algorithm that I've just discussed is called the parametric bootstrap. And this is different with the non-parametric bootstrap because the non-parametric bootstrap is where we repeatedly resample our data, and that's a measure that's a way to get standard errors around the original estimates. And you may need to do a non-parametric bootstrap as part of your estimation. If you're doing something like a two-stage conditional choice probability estimation, typically you're going to have to do bootstrapping, and I think I mentioned that in a prior video. You may need to do bootstrapping at multiple levels, but because this parametric bootstrap process that I've outlined on this slide is pretty intensive, especially if it's costly to produce even one counterfactual, then that is why it's not used very frequently today. But there's nothing preventing us from doing this theoretically. It's just about practicality. This wraps up our mini-series on model fit, validation, and counterfactuals. I hope that you've learned something new and enjoyed these videos. I know that I've enjoyed producing them. And in the next mini-series, we'll shift gears and we'll talk about how we can obtain preferences from hypothetical situations, not actual choices that we've observed being made. Thanks for joining, and I hope to see you in the next one.